Hello, my name is Alex Bowes, and today I'll be going through my design for a three-tier web application to be hosted in AWS Cloud. The design specifications for this assignment are seen here. As in the diagram, we see that there is a region such as US East 1, which is located in North Virginia. That one project VPC has been created, and within this project VPC there are three availability zones. Each availability zone containing a public subnet, a web private subnet, an app private subnet, and a database private subnet. There are 12 subnets in total, which are further broken down into security groups, such as the web security group, which for all the web private subnets, the app security group for all the app private subnets, and the database security group for all the database private subnets. There's further reference to a web elastic load balancer and an application elastic load balancer, as well as app auto scaling and web auto scaling groups. So the first thing that I did for this assignment was create the VPC called Project VPC. I did create one before, but it didn't work out alright, so I created a new one and added a suffix of a 1. So this VPC was created with an IPv4 CIDR of 10.0.0.0/16. When this VPC was created, it was initialized with a public subnet 1 and a web private subnet 1 in the availability zone US East 1A. But as well as those subnets, 10 more were created in conjunction with the actual design. So 12 in total subnets. We see that these subnets here that were created, they were given appropriate names such as the web private subnet and the app private subnet, as well as numbers to identify them. However, all of these, they were also assigned to their appropriate availability zones when they were created, such as US East 1B and US East 1C. After creating all of the subnets, their route tables were configured, such as the private route table, which has explicit subnet associations to the 9 private subnets, which are seen in the diagram, each of them being blue. We can see these associations here. So all of the private subnets are explicitly referenced here. Meanwhile, in the public route table, there are 3 subnet associations for the 3 public subnets that have been created. Also note that there is 1 public subnet per availability zone here. These route tables have been configured to determine where traffic will be redirected towards the appropriate subnets. So after creating the route table, I created the database, or the database subgroup initially, using Amazon RDS. The subnet group, DB subnet group, was created with reference to the database subnets as seen here. Point 10, point 11, and point 12, which are in set, which means it's a multi-availability zone subnet group. After creating this subnet group, I created the actual database, which is called Project DB. It was a MySQL database. Yes. Apologies for that. So the next thing I did after creating the database was create the EC2 instances. I created EC2 instances for the web and app tier. I began with creating the web tier base image. This instance was also created with the user data that was assigned here. It's an Amazon Linux 2 machine as well. I then created the app server base image, which similarly created with reference to the public subnet. It was fed the this user data. While creating these base images, their security groups were also created. The web tier and the app tier security groups, or the web security group and the app tier security group, excuse me. So after creating these base images, AMIs were created using them, such as the web tier base image, or web tier base AMI, excuse me, and the app tier base AMI. Just trying to, yes, there. Web tier base AMI and app tier base AMI. So after creating the base AMIs, I created the elastic load balancers. These are application load balancers as seen here, such as the web elastic load balancer and the application elastic load balancer. The web elastic load balancer is created here using the project VPC with reference to each availability zone, and has reference to subnets: public subnet 1, public subnet 2, and public subnet 3. The application elastic load balancer was also created using the same VPC, using public subnet 1, public subnet 2, and public subnet 3 in each availability zone. After creating the elastic load balancers, it is next to create the launch configurations that will be used for the auto scaling groups. I created the web tier group and the app tier launch configurations. These are to be ignored, they're from an initial attempt. They're created using the project key with reference to the security groups. The app tier security group, and the app tier security group. After creating the launch configurations, the auto scaling groups are created. These auto scaling groups are created using the web tier group and the app tier launch configurations. They were initially created with one instance, with a desired capacity of 1 and a minimum capacity of 1, as well as a maximum capacity of 1, because there was an issue when creating it that prevented the actual intended capacity. But after creating it with 1 capacity, if you went back and edited it to change it to the correct capacity here, it scaled up the number of instances that were created. Finally, I will demonstrate access to the web and application elastic load balancers as required for the assignment. This can be done by copying the DNS for each elastic load balancer and then visiting that DNS, which can be seen here. Also note when you refresh, the availability zone will change. Yeah, so that's the Web Elastic Load Balancer, and I'll now show the Elastic Load Balancer, or the Application Elastic Load Balancer. So it can be seen here, and it changes. So I have now demonstrated everything referenced for this assignment, such as the subnets, the load balancers, the auto-scaling groups, and access to the Web Elastic Load Balancer and Application Elastic Load Balancer. Thank you.